ring will move. The ring will move. The center of the ring will move along the axis, and whatever the particle also will move along the axis. Agree this. So now it will undergo. So finally, how to manage this particular question? What is the net force acting on the ring? What force will act on the particle? The same force will act on the ring also. So finally, the ring and particle will be here, and this ring will be like this. Now where do they will meet at? Where? Center of mass of system. So how do you can see? How do I can say means, what is the net force acting on, what force the ring will exert on particle? The same force the particle will exert on the ring, or the ring will exert on particle, or particle will exert on the ring. Net force acting on system is 0. Then from center of mass concept, so this distance, the ring will cover a distance x1, this will cover x2. Then net force acting on system is 0. Then center of mass will not shift. And what is this? This is the position of center of mass. Then from that m1 x1, m2 mx1 should be equal to mx2. So therefore 2x1 equal to x2. What is x1 plus x2? It should be equal to 4r. So x1, what is x2? 2x1. x1 4r by 3. So what is x2? x2 will be 8r by 3. Okay, but what was our question? Our question is what like? What is the speed of particle? The particle will have a speed, say v2. What about the ring? I think the ring I'll show it here. Huh? v1. So how to calculate this speed? Again, applying conservation of mechanical energy. Initial interaction potential energy, final interaction potential plus final kinetic energy. Initial interaction potential energy. So let me call this as point P. And this particular point as C. Okay, let me use that particular symbols. Now initially where the particle is at point P, so therefore potential at point P due to ring into mass m is the interaction potential energy. They are released from rest. Finally, where the ring will be there at C, and that C is now what will become center of mass of the ring also. Potential at C into, now don't write VC here. Okay, let me write VO only. Center of the ring it is now. What is O? O will become center of the ring. O and C will be at same point here now. So VO into M plus M V2 square plus 2M V1 square. Now let's write expression for potential. 2M G2M by root of R square plus 4R whole square. Negative sign into M is equal to potential at the center of the ring minus G 2M by R. Hope everyone is able to follow. What is V naught? Potential at the center of the ring. So finally when particle reaches the center of the ring and the particle will be at center of mass. Any reason why we should think in this way? Center of mass concept, where do they meet? They'll meet at center of mass of system. So minus G 2 mm and this will be mv2 square. v1, v2, two unknowns are there. So shall we go for conservation of linear momentum? m 2m v1 minus mv2. Solving 1 and 2 will get the required answer. How much of distance the ring has moved? It has moved a distance x1. And what is that x1? 4r by 3. What is the distance moved by the particle? 8r by 3. So some center of mass ideas also can be asked for you. You have to be careful. So always try to do some problems with multiple ideas. You can see conservation of momentum, center of mass, linear momentum, potential energy, all several ideas are included. Instead of this particle, you can assume a rod here, long rod, anything, bring that and release. And the rod is paved along the axis. Try to analyze, nothing wrong. Okay, after this, so like this, what happened? We can keep on work out several problems here. Okay, now let me take you to the now, yesterday's class, I told you, if you know the field, you can find out the potential. So let me just explore that mathematics. I'll come back to the earlier things. So we know this equal to minus dou V by dou R. So this potential, we can write it as minus E bar dot dr bar. Okay, now let me adjust m on both sides. M into dv equal to minus of. What is m into E? Force only. And what about this m dv? dv is what? Change in potential. So this particular quantity now will become f bar dot dr bar. What is m into delta v? It's a potential difference, mass into potential difference. So this will be, so we'll put limits here also. V1 to V2, work done to move from, or select A to B. There's a very important formula I'm writing. So this will become m into VB minus VA. So this negative sign, you send it on this side, m into VA minus VB. What you should do this, what is this one? This is like a work done by a force in moving a particle from A to B. What it is equal to work done in moving a particle of mass m from point A to point B in a gravitational field. Who does work? The gravitational force. Then what is equal to? Mass into potential difference between those 2 points. It's a very good generalized formula. V is not velocity. Capital letters I'm going to use for potential. Now work done by gravitational field, how do you can express? There's one basic formula here and all. So work done by gravitational field in moving a particle from point A to point B. What it should be equal to? Mass of the particle into potential difference between those 2 points. You directly get the work done. And this work done is what? Equal to change in kinetic energy. Again, work energy theorem. Like this. So here, so there's a use of that potential. It gives off lot of information than field. The potential, what happened, will give a better idea. We'll learn so many things can be calculated. So we can calculate the speed of the particle, everything. If you take the field concept, from field you'll get a force, F equal to ME. F equal to ME. Then force acts, then acceleration. Then acceleration means if you want velocity, again what happens, you should integrate. But here what it does, it will minimize the mathematics here. That's why the potential concept is introduced here. Able to get this work done in moving a particle from A to B in a gravitational field by a gravitational force is equal to mass into potential difference between those 2 points. So what is the meaning of this? Work done by gravitational field in moving a particle of mass m from A to B. There's the meaning of W1. And what is that? M into potential difference, VA minus VB, is equal to product of mass and potential difference between those 2 points. Later, as you go to the problems, no, this approach will help you a lot. Agree this. So now, what is the conclusion? If you know potential, you can get the field. If you know field, you can get the potential. That's a one firm idea. You remember it. Okay, let's come for. We'll get the potential due to solid sphere. And just statistical idea. Later on, I'll cover it numerical because numericals are totally just independent idea. It is. Now, field due to V due to solid sphere.